Hello students, here we are going to discuss about the distributed systems, and in the distributed systems we will be discussing about the distributed systems issues, client server computing and architectural pattern for distributed systems. Now uh, by distributed systems what we understand basically, they are we can say a distributed system is a coherent collection of some independent computers, okay, where the software system is distributed over those independent computers, and it appears to the users as a single system. Okay, so basically the processing is done in a distributed units, and but one from the user's perspective, it appears to be one single system. Now nowadays, because of the advances of the internet communication, the networks, the most of the large computer systems are actually distributed in nature. Okay, so it's actually very important in enterprise computing systems actually to have a clear view of the distributed software engineering. Okay, now why is distributed system so important? What are the advantages of a distributed system? Okay, these are some of the advantages of a distributed systems, where you can see resource sharing is one of the very important advantage, because there are so many independent computers which are interconnected in a distributed system. So sharing of hardware and software resource happens. Okay. Similarly, openness, where actually the equipment and softwares from different vendors are used. So that is another advantage. Uh, because all those systems which are part of the distributed systems uses different equipment from different vendors. Similarly, the concurrency, there are always a concurrent processing of the to enhance the performances. Okay, so that can be a shift, because concurrency can be a shift to have you know a concurrent execution of the processes. Similarly, scalability, that is, new resources can be added uh, to increase the throughputs of the system. Okay, so this is the this is what is the scalability of the system. That is, a distributed system is highly scalable. Similarly, fault tolerance. So fault tolerance is basically ability of the system to continue in operation after a fault has occurred. Okay, so distributed systems are likely to be very highly fault tolerant, because there are so many different systems which takes part in the system. So if even if a particular system fails, so the system as a whole will continue its operation. Okay, so these are some of the advantages of having a distributed approach to system development. Okay, distributed systems, as we have seen, have a lot of advantages, but there are certain issues in distributed systems which are much more severe, or you can say serious in nature, compared to the single processor. In the distributed systems, we see that the structures are much more complex compared to the single processor systems. So the complexity is one of the big issue in terms of the distributed systems. Okay, because but this complexity arises because there are different parts of the systems which are independently managed, as is the network. Okay, so since the uh, distributed system consists of independent computers, which are basically connected to the networks, but they are independent systems which have uh, the controlling authority is not there with a single person. So uh, so the complexity arises because of disconnections. Okay, like there is no single authority to connect from the top. Okay, to control the systems from the top. There are some design issues in distributed systems. Okay, these design issues are the transparency, openness, scalability, security, quality of service, failure management. Now, the transparency is like, to what level or to what extent should the distributed system appear to the user as a single system. So that comes in the transparency category. That is the to what extent should we allow the user to know that it's a distributed system. It's not that is or we can say to what extent should we allow the user to know that it appears to him as a single system. So or to make the users aware that actually it is not a single system, but it is interconnection of independent computers. Okay, so should that be allowed, or to what extent the person should have a illusion that a system the person is using is a single system, in spite of it is a distributed systems. Okay. Similarly, openness is another issue, design issue. That is the should the system be designed using standard protocol that support interoperability. So this is the question that determines the openness in case of the design of the distributed system. That is, should we allow should the system be designed using a standard protocol so that to support the interoperability, because the systems uh, which are interconnected are basically independent systems. So interoperability is a major issue here. So the standard protocols that we allow, should we allow those standard protocols to operate on for interoperability? So scalability is another, that is enhancement of the system, that is how we can make the system scalable. Okay, so that is the another design issue. Security, how can usable security policies be defined and implemented? Okay, so that is how do we allow a usable security policy be defined for the distributed system? That is another design issue. Quality of service, how should the quality of service be specified? Okay, and that is another design issue. Failure management, how can system failures be detected, contained and repaired? Because in case of the distributed systems, of most of the systems interconnected are independent. So how do we define we identify any failure in any single component in the distributed system? So that is the failure management. Okay, and how can we contain that those kind of failures? Okay, or repair the failure? So let us discuss those design issues one by one in detail. The first design issue that we encountered is the transparency. So transparency is basically is to decide on uh, to what extent should we allow the users to know that the user is using a distributed system. So ideally, the user should not be aware of the system is distributed, and services should be independent of distribution characteristics. But in practice, it is very difficult to make the user, you know, uh, unaware of the fact that the user is using a distributed systems, because it's primarily because of the network delays that the system can encounter because of the because of the independence of the systems which are connected in the network. Okay, so it is basically uh, we can say it is in fact better to make the user aware of the situation that the user is using a distributed system. Okay, so to achieve the transparency, the resources should be extracted and addressed logically rather than physically. Middleware middleware basically maps the logical to the physical resources. So it is to achieve this transparency, that is to have a single system view of the system, of the entire system, distributed system. It should be actually, the resources should be addressed and abstracted logically. Okay, so and we, as we know, that we use the middlewares basically to map those logical and physical resources. The other design issue is the openness. Open distributed systems are the systems that are built according to the general accepted standards. So basically, all the components are built with different, maybe with different programming language, okay, but they are connected. They are built with some standards. That is, by conforming to some standards, and therefore they become interoperable. Okay, so once those systems are being developed with keeping the or conforming to the standards of the development, then they become interoperable and they can be basically connected to one another to achieve the goals. So this is what is actually known as the openness. Another design issue is the scalability. Scalability is basically of a system reflects the ability to deliver high quality services as demand on the system increases. So it is the ability of the system to deliver a high quality service, okay, with the increase in demand. So scalability can be of different kind, like scalability with respect to the size, scalability with respect to distribution, scalability with respect to the manageability, right? So when we say scalability with respect to size, that means we should be able to add more resources to the system to cope with the increasing number of users. Okay. Scalability is distributed. Distribution is how widely or geographically dispersed the component of the systems without degrading its performance. Okay. That is how widely we can distribute the components of the system without degrading the performance. Manageability, that is it should be possible to manage the system as it increases the size, even if parts of the systems are located in independent organization. So that is manageability. So how well we can manage the system given the components of the system lies in different independent organizations. Okay, that is the manageability. Now, when you say scalability, there can be two kind of scalability. One is scaling up, another is scaling out. Okay, scaling up means the resources of the in the system with more power. That is the replacing of the resources in the system with more powerful systems. Okay, that is scaling up. Like suppose if we had a computer system with a memory uh, in the server as the 16 GB, and we are increasing the memory to 64 GB, so it is scaling up. Scaling out means when we add additional resources to the system. That is, suppose if we add an extra web server to work alongside the existing server, then it is scaling out. Another design issue is the security. Now, there may be security is a major concern in the distributed system because when the system is distributed, the number of ways the system may be attacked by the attackers increases drastically. This is because the components of the systems are widely dispersed and they normally are managed by different organizations having different security policies. Okay, so if a particular part of the system is uh, becomes vulnerable to the attacker, an attacker enters a uh, can break into that particular system in a particular part, then the entire system becomes vulnerable. Okay, so that because that particular from the part from where the attacker has made an entry, it can be used as a backdoor for the entire system. Okay, so security policy is design issue of the security policy is actually or the security system is actually a very important part of the distributed system. So there are different kind of types of attacks which the attackers can carry out in the distributed systems. So distributed system must basically defend against some of the very severe attacks. One such attacks is interception, because distributed systems are basically interconnections of independent devices. So when communicating from one device to the another device, the attacker may intercept the signals in between. Okay, so uh, So there can be a loss of confidentiality while the informations are passed from one system to the another system. Similarly, there can be interruptions where the system services are attacked and cannot be delivered as expected. Okay, so there are some say one such kind of attack is called as the denial of service attacks, because the denial of service attacks, the system services which are supposed to be for the genuine users are denied because some uh, malicious users are accessing the service. Okay, so basically the malicious service bombards uh, the system for a particular kind of service, and so the system becomes busy while for without knowing that it is serving a malicious user, and so it keeps on providing this while trying to provide the service to the malicious users. It basically denies service to the legitimate customers or legitimate users. Okay, so that kind of interruption is another type of attacks. Similarly, the third kind of attacks is modification, where data and services in the system are modified by the attackers or changed by the attackers. So that is the modification. Similarly, there can be another type of attack which is called as fabrication, where an attacker generates information actually that should not exist in the system. Kind of information that should not exist in the system is generated by the attacker and use those information to gain some specific privileges. Okay, so that is called as the fabrication. Another design issue is the quality of service. So quality of service offered by a distributed system reflects the system's ability to deliver its services services dependably. So and with a response time and a throughput that is acceptable to the users. Okay, so how dependably a user the distributed system can offer the services to a user is basically the quality of service. Okay, so while delivering the services, the distributed system basically specifies a threshold limit. Okay, so if uh, the quality of service falls below the threshold value, then the sound or the video quality is considered to be so degraded that it is impossible to understand that those quality. Okay, so it has to always keep its quality above a certain threshold value. Failure management is a very important part of the distributed systems. Uh, since distributed system is nothing but the uh, the combination of independent computers. Okay, so a coherent group of independent computers. So it is basically inevitable that there will be some failures at some part of the system. Okay, but the it has to be designed in such a way that it has to be resilient to those failures. So, but distributed systems should actually include the mechanisms for discovering if the component or system has failed, to discover which component has failed, suppose, should continue to deliver as many services as possible in spite of that failure. So if a particular component has failed, so the distributed system should continue to deliver as many services as possible, even if a particular, in spite of that particular failure of that particular system. Okay, and also it should recover as far as possible from that kind of failures. Now, models of interaction in a distributed system. There are basically two types of interaction between components in a distributed system can occur. Okay, that is how the two components in a distributed system can is interact or interact with one another. There can be two ways in which it can do that. One is the procedural interaction, and another is the message-based interaction. Now, in the procedural interaction means where one computer calls on the known service offered by another computer, okay, and waits for a response. Whereas in case of the message-based interaction, it involves sending the message from one computer to the another computer, okay, but there is no need of waiting for a response. So in the procedural interaction, basically the computers uh, calls for a calls on a known service, that is the service that is known to that particular computer, okay, and also it waits for the response, okay, whereas that necessity is not there in case of the message based interaction. That means the computer may not know the other computer, but it can send a message with a specific information asking for certain queries, whereas where it may not wait or may not choose to wait for the response from that computer, okay. So that is the message based interaction. An example of this the procedural interaction can be shown to have a interaction between the dinner and the waiter, okay. You can see a waiter on this side and the diner on this side. So diner, the waiter asks the diner, what do you like to have? Similarly, the diner says the tomato soup please, okay. So this kind of interaction, that is one asking for the service, another is and then waiting for a response, okay. So they know the services. See, the each of the waiter knows um, the diner knows what kind of services the waiter can give, okay. So they know the service and they interact with one another and wait for the response of the other part, okay. So that is how the procedural interaction works. In the message based interaction between the waiter and the kitchen, see here the starter has given a particular composed message here, okay, the starter message and the main course message, okay, and the accompaniment, and then sends this message to the kitchen, okay. So waiter basically, after taking the diner's uh, menu, what diners want to have, what waiter will do, waiter basically will create compose a kind of category of the things that the diner wants to have. So it is going to send this as a composed message to the kitchen person. So what it will do, all that information that has been supplied by the diner will be composed into a message. So starter is the what starter that particular diner want to have, what main course the diner want to have, what accomplishment diner wants to have. All these will be composed into a message and give to the kitchen. And then it will go for serving another diner without waiting for kitchen's response. So whenever the dish gets ready, the kitchen will call the waiter to deliver it to diner. So till then, the diner or the waiter will serve other diners. Okay. So the procedural interaction between the two components in the distributed systems basically operates through the remote procedure calls. Okay. In a remote procedure call, one computer knows how to call on the other computer. There is the method to call the another computer, and that is done through the middleware. Okay. So uh, a problem with the RPC is that the caller and the callee needs to be available at the time of communication, okay, and they must know how to refer to each other. In a message-based interaction or message passing, uh, it basically involves like one component creating the message that details the services required from the other component, okay, and then once that message is composed, it is sent to the other component through the system middleware. Now, once it is it reaches uh, the other part, the receiver part. The receiver parses the message and carries out the computation as it is specified in the message. Okay, and then it it creates another message and send that component to the required result. That is it composes another message of the result and sends it back uh, to the original creator of the message. Okay, so in the message based approach, it is not necessary for each of these sender and receiver to be aware of each other. Okay, and they simply communicate via the middleware. Middleware is basically one of the very important part of distributed systems, because the components of the distributed systems are are all of different kind, or maybe of different kinds, which are implemented in different environment and managed in different ways. Okay, so middleware is the software that basically manages these diverse components uh, of the distributed systems and enable the components to communicate with another components without any hiccup. Okay, without any thing going wrong in between them. So basically, middleware's work is to translate the information efficiently from one component to the another component while communicating. Okay, so that the every component is can uh, take or accept the information from the other component. Okay, so the middleware includes software for managing communication with the database, transaction managers, data converters, and communication controllers. So here is the diagram that shows the middleware in the distributed system. So middleware exists here. You can see in the system 1, here is the middleware, and the system 2, here is the middleware. So middleware basically enables the two systems to communicate with one another when the information is being passed. So application components of the systems interact with the other systems via a middleware, so that they can easily communicate with other parts of the distributed systems. So distributed systems which are normally available in the internet are basically the client server systems, where we have a clients which are the local users, you can say users who interact with the program running in their local computers. So we can say web browsers and the phone-based applications are the client applications, whereas there can be a application which is running in a remote computer and which provides the services, and normally we call those as the web servers. Okay, so remote computers basically provide services such as access to the web page, etc., and which are available to the external clients. So clients basically access those web servers through different client programs like web browser, etc. This is a typical diagram of the client server interactions, where we have see there are some clients which are connected to the server S1. Similarly, to S2 there are 3 clients. Similarly to S3 there are another 3 clients. For S4 there are 2 clients, and these remote servers are basically connected to one another. Okay, so this is a typical structure of the client server interactions, where each of the servers provides services to its own clients. Okay, so in the client server computing, as we have seen in the last figure here, that is there are the client and server processes. Uh, these are the client and server processes actually, rather than processors. So uh, they it is basically those processes run on a single processor. Okay, uh, we can have a PC basically that can run a mail client that downloads email from the remote mail server. Okay, or we may also run web server that interact with the remote web servers to print client that sends documents, okay, to a remote printer. So all these activities can be done from the client side by taking help of the services provided by the remote server. Okay, and also we can have another kind of configuration, say, where that shows actually where it is the uh, how these processors are, or how the clients are allocated to the physical computers, and servers are basically they are also mapped to some physical devices. Okay, so the 12 clients that we have here, which are actually connected logically to the different servers for services, can be basically accommodated, suppose, in the 6 computers. Okay, here, and similarly the 4 servers that we see here, maybe they are connected to the 2 server computers. Okay. So we see here, we can see those 12 clients basically connected to the 6 computers here. They are the process running on 6 computer processor through a base network here, and there are 4 servers which are mapped to 2 different servers, physical servers, where those server computers, server machine runs. Okay, server program runs. Here is a layered architectural model for client server application. So for the client server application, the layered architectural model is shown in this particular diagram. The presentation layer, data management layer, application processing layer, and database layer. Okay, these are the layers which are used for the client server applications. So key points from the discussion that we have done is that the benefits of distributed systems are that they can be scaled to cope with increasing demand, can continue to provide user services if parts of the system fail, and they enable user resources to be shared. Okay, so these are the benefits of using the distributed systems, because scalability is possible. Okay, so resource sharing is possible, and also fault tolerance is possible. Okay, similarly, issues to be considered for designing the distributed systems include transparency, openness, scalability, security, quality of service, and failure management. Client server systems are structured into layers, with the presentation layer implemented on the client computer, and servers provides data management, application, and database services. Client server systems may have several tiers with different layers of the system distributed to different computers. Thank you.